Hey everybody, this is Games Plus James, and welcome back to our Unity 2-player tutorial series. So, we've now added some animation to our player, so that was as we're moving around within the world. If we start going here, we can see we now have some animation going on, and it makes it look a bit more fun as we're going. So the next thing we need to do is make it so that our player can actually throw the snowballs that are going to be an important part of the game itself. So, to do that, of course, we're going to actually need to make the snowballs. So we'll go to our art folder, where we have our sprite sheet, and we're going to grab the snowball sprite, and I'm just going to drop this into the world there like that. And remember, in the first episode we shrunk the size around the snowball, but just in case you didn't do that at the time, make sure in the sprite editor that the snowball, the shape around the snowball, is the same size as the snowball itself. Functionally, it won't actually make anything too crazy of a difference, but it's just handy to kind of keep your things framed around the right size as you go. So we have that there. So obviously, having a snowball, we need to give it the ability to interact with our players. So to do that, we are going to add we'll go with a circle collider. Circle collider 2D. We're going to make it a trigger, so it'll interact with our player rather than just hit off him and knock him backwards. And do weird stuff that we don't really want to happen. I'm going to shrink down the radius just a little bit so that it's not quite as big as the snowball itself. We actually want it to be a little bit smaller because that's just how it's kind of counterintuitive. You don't want it to be the exact same size as your snowball. You want it to be a little bit smaller so the players have a little bit of leeway. It kind of just makes the game feel better. Again, it's one of those things though that you can experiment with yourself, adjust the radius to whatever size you feel comfortable with, and go with that. So we have our snowball there. Next thing we need to do is add a rigid body, because we're going to want our snowball to be flying along through the air. But we want, on our rigid body, we want to set gravity scale to be 0, because we don't want our snowballs falling down to the ground. We want them just traveling side to side in a straight line. I'm also going to rename the snowball rather than just being named automatically from the sprite sheet. We're just going to call it Snowball, nice and simple like that. So we have the basics of our snowball here. Of course, at the moment it doesn't do anything. All it does is, if we hit play, all it'll do is just fall down. It won't even hit the ground, actually. It'll just disappear through it. Oh, sorry, no, we turned gravity off, of course, so it won't actually do anything. It'll just hover there. If we gave it some gravity, it would fall down, but at the moment it does nothing else. So we need to create a script to actually move our snowball around within the world. So we're going to create a new C# script, and we'll just call it Snowball, nice and simple. And we'll open that up in MonoDevelop, and just while that is opening, I'm going to go to the snowball itself. It's just kind of compiling this new script that we've created. So I'm going to go, let that open up. We're going to go to our snowball, and before we do any more, we're going to drag that script onto the snowball object so that we know it's attached. We don't have to remember to attach it when we inevitably forget when we go to run the game later. Okay, so on our snowball, we have a couple of things that we need here. We need to have how fast it's going to move. So we'll have a public float called ball speed. And we also need to know about the rigid body that's attached to this snowball, because if we're using the rigid body forces to move our object around, we obviously need to know where it is that we send our forces to. So we'll have a private rigid body 2D that we'll call DRB, or for the rigid body. So in our start function, as we've done before, we need to say the rigid body is equal to get the component that's attached to the same object that this script is attached to. And the component we want is the rigid body 2D component. Let me actually just go back and make sure. Yeah, I did. Just for a second I was thinking, did I actually put a 2D rigid body on and not a normal one? Okay, so we have that. The next thing we want is basically to just move our snowball along as it floats in the air. So we want to apply a move speed to it. So we have we will be given the speed of the ball. Say we have that at 15, say. To move it to the right, we obviously want to apply a force of 15 to the rigid body, which is fine. We've done that with the player. But if we move it to the left, we want to apply a force of minus 15. Again, we've done that with the player, so we know how to do that. But we don't know in which situation we would do that. So there's a couple of ways we can do it. For example, when our player fires a snowball, we could have the player script then set this value here in the ball speed to be either positive or negative depending on which way the player is facing. But that can get a little bit confusing, and we have to then find the snowball script that's attached to the individual snowball, and it's kind of just adding extra processing time that we don't need to worry about. So what we'll do instead is just base it on which way the snowball we'll base it on which way the player is facing. So we worked that out by, if you remember in the last episode, we set the scale of the player to be either 1 or -1. So if we're 1, we're facing to the right, and if we're -1, we're facing to the left. So what we can do is say, if when we're firing our snowball, if our player's scale is -1, then we'll make our snowball scale -1 as well. And then in this script here, what we can say is our speed should depend on which way or which scale our local scale x has. So what we can say is on our rigid body dot velocity. So if we just wanted to set it to move to the right, as I said, it'd be very straightforward. We just go new vector2, and we would have the ball speed, and then we would obviously not want to change the rigid body velocity dot y. Actually, we could just leave that as 0 because we don't want our snowballs moving up or down at all. So we could just put that at 0. 0 like that. Now, as I was just saying, we want to base which way the ball is actually going depending on our local x scale, or our local scale on the x-axis. Sorry. So what we can do is say our ball speed, we will multiply that by transform dot local scale dot x. So what will happen there is if the snowball is the normal way around, so the x value is 1, then our ball speed will be 15. But if our local scale has been swapped around, so we're facing the other way, then our ball speed will be -15. So perfect, that's all we want to do with that. We're going to save that there. And that's kind of the basics of our snowball script. So if we go back into the game, let it compile for a second, or back into Unity even. I'm just going to switch this view. I'm going to trigger maximize on play so that it always goes to the big view. Oh, actually, I hit play there, but we didn't give our snowball any speed, so it won't be moving anywhere. So on our ball speed, like I said, we'll set that to 15. Again, that's just a number I've picked. You can adjust that value to be whatever you want it to be. But you can see there, our snowball flew off to the side just the way we wanted it to. So the next thing we need to do is make sure that when our snowball hits against something, it doesn't just keep flying off to the side. We actually want to make it kind of disappear. So what we'll do is, on our snowball script, we're going to add a new function down here. We're going to add a void on trigger enter 2D, and then in here we're going to say collider 2D other. So if you haven't come across this before, basically all this is just because we made our snowball, we gave the collider that's attached to our snowball, which is our circle collider here, we made it a trigger so that it's not a solid thing, but it's like a zone of magicalness. But what it does basically is say, okay, if this trigger interacts with another collider of some kind, then we're going to do an action. So the most basic thing we're going to do here is say, okay, if our snowball interacts with anything else, we're going to say, okay, just destroy our snowball. Like that. But if our snowball just gets destroyed, that's not very exciting. For example, if we just play the game here, again, you have to wait a second for it to compile, but if we play the game here, we'll see our snowball. Actually, I'm just going to turn off maximize because we're going to watch our snowball here in the hierarchy. You'll see it disappear when it runs into the wall, but visually we don't see much at all. It just kind of suddenly it's gone. It's not very interesting. So what we're going to do is create a simple and very straightforward little particle effect that will kind of demonstrate our snowball being there, and then it'll kind of get rid of it nicely for us along the way at the same time. So The most simple way to do this is just go to game object up here, and we're going to go to particle system, and you can see it starts this thing firing up into the air like that. That's not what we want though. We want to set the rotation here to be 0. Then we're going to do a couple of other quick little changes. We don't want it to be continually emitting things. We want it to do under bursts here. We want to set this to be, say, 10, 10 and 10. That's fine. And we want to have the size of them be nice and small, say 0.1. And we want to have our gravity modifier be 1, so it falls down. Actually, no, not quite that fast, but 0.5. Our start speed, we want to be just 1, I think, should be okay. Yeah. You can see there's actually a bit of a delay, and that's because we have it on looping here at the moment, and we have our duration being 5 seconds. But we don't want it to be that long. We only want it to be a second long, and we only want the lifetime of our snowballs to be 1 second also. So they just kind of fall down like that. To make them look like they're disappearing as they fall, we're going to scroll down here to size over lifetime, and we're going to drop this down, and we're going to click on this big grey box here, and then down the bottom we're going to grab the diamond that's on the right here, drag it down to the very bottom like that, and you'll see the snow kind of looks like it's fading away almost as it goes down. We're going to go to shape here, and instead of being a cone, we're going to set it to be a circle. And then we're going to make the circle way smaller, so it's much more like our snowball here. So we're going to grab the radius and just kind of pull it down to there like that. So now we have a kind of a little effect that looks like a little burst of snow kind of flying out. So the next thing we're going to do is make sure that this is not looping, because every time it hits the wall, we don't want it to play forever and ever. We just want it to play once. So now that we have that there, we're going to rename this to be our snowball effect. Then in our prefab folder down here where we have our platforms, we're going to drag the snowball effect into there. So we have it there like that. I'm going to delete it from the game itself. And then back on our snowball, we're going to go into our script. We're going to add a new reference to that snowball effect object. So we're going to say public game object. We'll call it snowball effect. Just keep it nice and simple like that. And then down here, when we destroy our snowball, just before we destroy it, we're going to say instantiate, which is what creates an object within the world. So instantiate the snowball effect. We need to give it a position where it will instantiate at. So that'll just be where our snowball currently is. So transform.position. And we need to give it a rotation, which again will just be whatever our rotation of our snowball object is. So just transform.rotation, and that's it. That's what will create our little snowball effects within the world. So we go back in here, let that compile for a second, and then we of course need to match this up on our snowball script. So we've got our snowball effect. We'll drag this into the slot here, and we'll hit play, and we'll see, boom, we get a nice little snowball effect coming out of our snowball hitting the wall. So now that we have our snowball there, let's actually add the ability for our player to throw the snowballs. So if we're going to have our player repeatedly throwing the same snowballs, we're obviously going to need to make this a prefab object. So I'm going to drag this and drop it in there, and then we're going to delete this original snowball from the scene. Then we're going to go to our player, and we're actually just going to go into our player controller script over here, and we're going to add a new reference to the snowball object. So we're going to say public game object snowball. Oh no, just one small a like that. And now that we have our snowball object and we know what the snowball is, we also need to know where on our player the snowball is going to be coming out of, because as we said, we had, when we created the snowball effect here, we had that instantiate the object at a position. So we need to know where is the snowball going to be coming from when it's thrown by the player. So we're going to go into our game here, and we're going to right click on the player and create an empty object, and we'll call this the throw point. Nice and straightforward. And then we're going to drag this so it's in front of the player here, so it's not actually touching against the player. And then back in our script, we're going to add a public transform that we'll call our throw point. Save that, and then when we go back in, we can hook up this into the correct slot on our player. And now that we have the point that we are throwing the ball from, and we have the snowball object itself, we can add a new input statement here. So we'll add an if input.getKey down, and the key we want to have down is the throw key that we set up in a previous episode. So if that button is pressed, where have we got an error here? Oh, sorry, that should be throw. What do you say? Throw ball, because we can't just do throw, because that would create an error. So we have the throw ball there. So basically what we do then is, okay, we press this throw snowball button, so instantiate a new snowball, which is our object, at the throw point position. So throw point dot position, and we'll also use our throw point dot rotation, like that. So we can save that there. And now that we have those, in the previous episode we set up our animation so that we would have a throwing animation. So when we throw the ball here, we also want to use the animation trigger that we set up. So we will say anim.set trigger, and the name of the trigger that we used was, let's just double check so we get the right one. Yeah, it was throw with a capital T, like that, because as I said before, you need to make sure that you use the exact right thing. Now there's one thing missing from this, which is setting the scale of our snowball, but we'll return to that in a minute, because we want to do one thing at a time. One thing you always want to do when you're coding is do one thing at a time and then test that and make sure that it's working before you do another thing on top of it. So now we know that we should have everything set up for our player to be able to throw a snowball. So we'll go down to our player controller script. We have a slot here for the snowball, so we'll drop that in there, and we have a slot for the throw point, so we'll drag this into there like that. And now what button did we set up for throwing the ball? It was F. So now when I throw a snowball, boom, we can see it hits against the wall just the way we want, like that. But if we turn the other way, our snowballs are hitting against ourselves, which obviously we don't really want at all. So I'm going to stop that there. And like we said, we set up our snowball so that depending on which way it's facing, depending on which way the local scale is, then that'll determine how fast it's moving, either left or right. So on our player controller, what we can do is, instead of just saying instantiate the snowball, we can actually say that we're instantiating this snowball as a particular game object. So what we're doing here is creating a new game object that we'll call ball clone, and we're setting it to be equal to instantiating this object in the world, and we want to put in front of it, we just want to put in brackets game object, so that Unity knows that the next thing that's coming here is going to be a game object, so that when this thing tries to fill in a game object as the ball clone, basically it knows that it's not going to do anything weird. If you leave this off, basically you'll get an error in Unity and it'll say, oh, we can't do anything. So you just need to stick that in front and it'll work just fine. And then now that we have this kind of reference to the object that we just created, we can say, okay, the ball clone that we just created here, the ball clone's transform.local scale should be equal to whatever the transform.local scale of the player is. So this script obviously is attached to the player. We know that it will always be attached to the player, basically. So what we can say is, okay, if the player is facing left, so if the x is -1, then we can say the x on the local scale of the snowball should also be -1. So we can save that, pop back into the game, and now we should see that our snowball will fly either off to the left or to the right, depending on which way we're facing. So if I just let this play, now we can throw them to the right just like that, and we can throw just like that. Now you can kind of see here that our throw kind of animation for the player is lasting a really long time after he's thrown the ball. So that's too long. We don't like that. So we'll go into our animator and go to this transition from the throw animation to our idle, and instead of having it at exit time of 0.5, we'll bring it all the way down to 0.1, and we'll test this out. And as I said before, all of this is always about kind of feeling around and seeing how the game feels for you. So there we go, that's a nice quick little throw. Now it looks like our player is throwing and then running, and it looks a bit more reasonable. So now we have these snowballs that we're able to throw around, and when we're throwing around all these snowballs like crazy, there's one little problem that we're creating, and that is that every time we make one of those particle effects hitting against the wall, it's creating a new clone of the particle effect, and it's filling up our hierarchy here. And as the game goes and you make hundreds or thousands of these snowballs, if you're really bad at hitting each other, what can happen is that it might start filling up the memory and our game will start slowing down. So that's not what we want. So what we'll do instead is we're going to make a simple little script that will make sure that our snowball effect destroys itself after a certain amount of time. So we're just going to go into scripts here. We're going to create a new C# script that we will call destroy over time. And this is one of the most kind of simple little scripts that is really handy to kind of reuse for lots of things. So on destroy over time here, all we need is a certain amount of time that we want whatever the object is to last for. So we'll say public float lifetime, and then in our update loop here we just say lifetime minus equals time dot delta time. So time dot delta time, if you haven't encountered it before, is the amount of time it takes between one frame of the screen to update to the next. So it'll be a very, very small number, like a 0.005 or something like that between each frame. But as each frame goes and each update loop starts, and again it'll take away the length of time it took since the last one from lifetime. So basically it'll just make a countdown in real time. So say if we set lifetime to be 1, that'll last 1 second. So we'll say a lifetime minus equals time dot delta time, so that makes it count down. And then we'll say if our lifetime is less than 0, then what we want to do is just destroy the game object. So whatever game object this script is attached to, after 1 second, or after whatever lifetime amount we set, it'll be destroyed. So we can go back into our script, or sorry, back into Unity, and then we're going to go into our prefabs here. We're going to go to our snowball effect, and then down the bottom we're going to add the component we just created. So that is the destroy over time script. So we have it here, and then on the lifetime we're going to set that to be 1 second. And then if we play the game again, what we'll see is as we throw our snowballs against the wall, we get the effects created and then destroyed. So our snowballs are destroyed, and then the effects that are left after them are destroyed too. So there you go. That's how to get our snowballs working within our game here. Next thing we're going to take a look at is how to add a second player into the game and actually start having a little bit of fun as we run around here. So thanks for watching, and I'll see you all very soon.